Welcome, this is Algebra 1, Semester 2, Unit 11. I decided to record backwards on these just so that if you have been in class, you'll have a complete set of notes quicker than those who have not been in class that need to go on and get the other notes as well. Now, during any of these videos, if you don't have the basic skills that should have been gained by being in class and doing the work, actually studying the material in that unit, then you need to go back to the unit and study more of the material, more of the notes, and actually Google some of the topics and pursue it. Learning is, a two-way street here. I can give you everything possible to help you, but you've got to grab a hold of this and really learning math is so empowering, you guys. If you can just hang in there and really, the hardest part is to learn. Your brain has to hurt. But once your brain hurts a little bit in learning, then you really understand it. These videos allow the skills to be a little bit spoon-fed to you so that when you get into class with activities, you have that basic understanding in order to sort of springboard off of that. So please, please, please study these videos. They're required for you to do well in the class, or at least gaining the knowledge of the basics is. You could also look up topics and go to other YouTube videos, or Google it and read, search it out. You can find it. This is for Unit 11. Unit 11 is on stats. So let's get right into this first problem. This first problem has to do with a supervisor at a factory is testing the company's packaging materials for accuracy. In this unit, we talked a little bit about accuracy. Accuracy is the ability to hit a target. Okay? So we're going to be looking in here for a target. The machines were labeled X, Y, and Z. That's how they have them labeled right here. And they're saying the company standard for packaging a product is that each bag should contain 6 to 8 ounces. Okay, that's our target. So which of these machines is most accurate would be which machine hits within that target with the majority of its product. Okay, so that's going to be our accurate. I'm sure they're going to ask for that. Go down to the question. Based on the data plots below, which statement is correct? And then they are talking about accuracy. So let's just go ahead and find out which one is most accurate. Most accurate. Okay, we want to see 6 to 10 ounces. That's from here to here. Machine X has 1, 2, 3, 4, 5. Machine Y has 6 to 10. 1, 2, 3, 4, 5, 6. Ooh, Y is a little bit more accurate than X right now. From 6 to 10. 6 isn't even on here. Oh well, we have 1, 2, 3, 4, 5. 5 right there. So the most accurate would be machine Y. Okay, now let's see what else they talk about here. It says the supervisor randomly chose 10 bags from each machine and recorded the results in the table below. Okay, now we're supposed to find the statement that's correct. Machine X is, they're going to talk about consistency too. We may be able to spot the answer just off accuracy, but it's real important to me that you know consistency. Consistency means that the product that the machine is giving is within a tight range. So we want to look for the smallest range. Smallest range will be the most consistent. Okay? So the range again is your highest minus your lowest. Our highest here is 11 minus 3 is 8. Our highest here is 12 minus 5 is 7. And our highest here is 14 minus 8 is 6. So our most consistent would be machine Z. So let's look at this. Machine X is both most consistent and most accurate. No, it's neither one. Machine X and Y are equally consistent, but machine Y is most accurate. Are machine X and Y equally consist? No. They have a consistency that's different, so that one won't work. Machine Z is both the most consistent and most accurate. No, machine Z is the most consistent, but not the most accurate. Machine Z is the most consistent, but machine Y is the most accurate. There we go. There is our answer. Okay, a fast food chain. Fast food chain. Let me get it all on there for you. It's taking a random survey of their stores to find the average number of sodas they sell per day. The data collected is given below. Which measure of central tendency best represents the data? Justify your answer. Okay. Well, one thing that's real important, I see an outlier right here. Right there. And if we have an outlier, if there is an outlier, do not use mean. Do not use mean for the most accurate method of measure for central tendency, because a mean is influenced far more by the outlier than any other measure. So we don't want to use the mean. It wouldn't be best. Mean, best, nope. Mean would be best because there's not an outlier. Well, there is an outlier. So, nope. The median would be best because there is an outlier. That is absolutely true. We use the median anytime there's an outlier. Okay. Two-way frequency table shows all the grades for males and females in a science class. If the females were to have the same percent of B's as the males, how many more females would need to get a B in the class? Okay, so we're looking for percent out of the whole class. That means we need a total for our percent. So for the males, we have 3, 6, that's 9, 10, 11, 12. For the females, we have 9, and 4 would be 13, 15, 16. And this is out of the whole class. Is that right? Let me just read it close. If the females were to have the same percent of B's as the males. Oh, no, we don't need to worry about the whole class. We just need to look at the B's. Okay, so the males have 6 out of 12 with B's. If we reduce that, that's equal to 1/2, or 0.5, which is 0.50, which is 50%. Well, if we think about this for females, if there's 16 females, we would need to have 8 females have B's in order to be at 50%. And that's what it's asking, is how many more females would need to get a B in the class? We have 3, we need 8. 8 minus 3 would be 5, so 5 would be your correct answer. Okay. Use the table below to help determine which function has the greatest value as x gets larger and larger. I would hope after our study in linear, in our study in quadratics and cubics, and then our study in exponential, that you would already have an idea. But let's go ahead and show how you work this out, because I do want to see the work on it. You would plug 3 in for x in each situation. 3 plus 3 equals 6. 3 plus 4 equals 7. 3 plus 5 equals 8. 3 plus 6 equals 9. Here it's 3 times 3 equals 9. 3 times 4 equals 12. 3 times 5 equals 15. 3 times 6 equals 18. Okay? And you're looking at, wow, this one gets a lot larger than that one. What's going to happen over here? I'm not going to fill out this entire chart for you, but once you fill it out, you'll find which one's largest. If f of x is the largest, which we already know it isn't, because it doesn't have a greater gain than f of g, so we could go ahead and mark it out. If it's g of x, this will be the highest one. We'll just go ahead and show you how to do these. 3 to the third, that's 3, times 3 is 9, times 3 is 27. Now we plug in 4 for the x, so it's 4 to the third. You already had to memorize perfect cubes, so you know that's 64. 5 cubed, figure that out if you don't know, then 6 cubed. Here we have 3 to the third. Well, we know that's 27. 3 to the fourth, figure that out. 3 to the fifth. 3 to the sixth. Whoops, not 3 times 6. 3 to the sixth. Calculate those and you decide which function is it that gains the most the quickest. Okay? As it gets larger and larger, which one's the largest? So you mark the correct one. On number 50, I love this little problem here. It really makes you read a little bit and think about it. Maximum height reached by a bouncing ball is given by, oh, do you all recognize this formula? Exponential formula, it's ab to the x. Now remember, this is the common ratio. That's how much it's gaining or losing on each bounce. And if you look here, it's losing because it's less than 1. So it's not a super ball that would gain and get bigger and bigger forever and ever. That would be a cool movie, as we talked about. 10 is our starting height. Starting amount. Okay? So, h is measured in feet and x is the bounce number. Describe the domain of the function. What it means when x equals 0. Well, if x is 0, 10 times the bounce to the 0th power, anything to the 0th is 1. What would that 10 stand for? Okay. Let's go down and just kind of browse these. It says, when the bounce number x equals 0, the height of the ball is 10 feet. Well, that would make sense. It is 10. Okay. So that one I kind of agree with. When x is 0, the height of the ball is 7.5. No, we didn't get 7.5 here. You would only get that if you didn't raise it to the power before you multiplied. And then you'd even get a weird thing there. So no, can't go with that one. Here we're at 10 feet again. I like that one. Here it's again talking about it being at 7.5 feet. Mark that out. Now, what's the difference between these two answers? Well, if you look closely, the difference is the domain is all non-negative numbers. This one, the domain is all real numbers, so we could have negatives. What did it say that our domain was? What is our x representing? The x is representing the bounce number. Can we have a negative number of bounces? Think about that. You choose the right answer. I think you know now. Thank you very much. Have a good night.